Welcome to the Best Writing on Mathematics channel. In this video, I will summarize the contents of the 2010 edition of the print series with a similar name. I will tell you some other time the unlikely story of how I came up with the idea of such a series and the interesting path I had to go through until I finally started it in 2010. For now, let's talk about this volume. Here, Chandler Davies argues that truth in mathematics has various strengths and that accepting this notion makes mathematics pertinent and relevant. He notes that mathematical theories worth their name are more than collections of truths. They concern the nature of conceptual relatedness, not only its existence. Melvin and Nathanson discusses several difficulties in finding perfect, beautiful, insightful proofs for mathematical results and gives reasons for valuing these qualities over deductive proofs exclusively concerned with formal validity. Branko Grünbaum details several errors of enumeration in the geometry of the polyhedra. He shows that some reside in logical flaws and proved surprisingly enduring despite extended scrutiny of this subject over many centuries. Keith Devlin points out that past mathematicians often solved problems by trial and error, but such experimentation disappears when they finally published the results. Nowadays, with the advent and even more widespread use of computers, distinctions between formal mathematical proofs and proofs by experimentation are likely to become blurred. Henryk niakowski describes the context and the parameters of employing mathematics to study the complexity of continuous problems generated by systems with partially available information. Answering yet another "what is mathematics?" origins of financial mathematics in the development of probability as abstract measure theory by the Russian mathematician Andrei Kolmogorov in the first part of the 20th century. Johnson continues by sketching a brief list of the virtues and the dangers of using mathematics in finance. In a piece with an amusing title, David Wagner invites us to give credit to the forbidden language of mathematics. Wagner argues that by turning to taboos and examining them, we escape the conformity inherent in the normative ways of practicing and teaching mathematics. Freeman Dyson draws on his long familiarity with the work of past mathematicians and recalls his personal acquaintance with mathematicians prominent during the 20th century to observe that some were better at identifying broad unifying concepts in mathematics, while others savored solving particular problems. He considers both styles equally valuable and necessary. Robert Thomas discovers ludic aspects of mathematics and their virtues, but also the limitations of conceiving of mathematical activity as a game. He thinks that communicating well is an essential part Unlike in playing games, mathematicians are allowed to disobey strict rules as long as they can make a compelling case for doing so. Timothy Gowers and Michael Nielsen describe a novel experiment in mathematical research, opening it up to the world, making it available for everybody to see, engage, and enjoy. The Polymath project they present proposed finding an elementary solution to a particular case of a combinatorial problem. The result was a more effective collaboration than the initiators had expected. As we look into the future of mathematics as an activity, this experiment might well constitute a consequential breakthrough. Philip Davis and Alicia Dickinson in separate contributions write about mathematical reverberations in the work of a poet, Paul Valéry, and the physicist, Albert Einstein. Davis, following the Valéry exegete Julie Robinson, explains that the ubiquity of mathematical notes in the poet's famous cahiers is far from accidental. Instead, they betray Valéry's notion that mathematics succeeds in weeding out the opacity, vagueness, and ambiguity of ordinary language. Dickenstein's note traces the story of Einstein's first page of the original printing of his seminal 1905 article on the theory of relativity. That page, apparently lost through the mishandling of a paper copy in the process of reprinting, happened to contain Einstein's unambiguous and early recognition of important mathematicians as predecessors in the formulation of the general theory of relativity. This recovery, partly based on archival material, is not only valuable in itself, but supports a line of counter-arguments to a sizable, controversial, and conspiratorial literature claiming that Einstein was indebted without acknowledgement to the mathematical methods perfected by some of his mathematical predecessors. Walter Willinger, David Alderson, and John Doyle reconsider the relevance of mathematical modeling as an explanatory means for understanding the Internet. In a compelling piece, they caution that scale-free network models ignore the idiosyncrasies and ambiguities characteristic of domain-specific data collection. Brian Hayes difficulties encountered in manipulating the ever-increasing gigantic numbers that pop up in computing, finance, and astronomy. The currently used floating point methods are inconvenient for several reasons, most problematic being the overflow of digits. Hayes ponders the advantages and disadvantages of three other possibilities: the tapered floating point, logarithm replacement, and level index systems. Theodore Hill looks at the problem of timing, of when is best to act or to cease to act in circumstances of variable uncertainties, from economic competition to war to marriage to betting and beyond. He describes optimal strategies for stopping in situations where only partial information is available. He also gives a few examples of stopping problems that are simple to formulate and to understand, yet they remain unsolved. Barry Cipra notes that applied mathematics increasingly uses topological ideas in the form of homology, a mathematical so-called mechanism that makes sense globally and of meaningless data gathered locally. Using homology, information recorded and transmitted by randomly distributed sensors can be analyzed with respect to matters concerning coverage, constraints, uncertainty, and optimization. In an insightful essay on mathematics education, Anne Watson situates school mathematics in the broader context of the transition from adolescence to adulthood, underscoring both the tensions and the possibilities it holds. Her student-centered vision, enhanced by Vygotsky's ideas concerning close adult support in students' learning, echoes Dewey's century-old call for transforming education into an institution that prepares youngsters for becoming in communities. Kathleen Ambruso-Acker, Mary Gray, and Behzad Jalali present the legal, practical, and implicitly ethical ramifications of accommodating the learning space to the requirements of students with disabilities. This subject is rarely discussed with respect to mathematics instruction in higher education, but is present with increasing frequency in court disputes involving colleges and universities. David Pym and Natalie Sinclair discuss different styles of mathematical writing, another topic seldomly thought about by many professional mathematicians and educators. The authors note that writing in mathematics is generally impersonal and contains implicit assumptions not always assumed by the reader or made plain to the learner. In her solo text chosen for this volume, Natalie Sinclair further elaborates on aesthetic aspects of mathematics. She examines the alternative elitist and frivolous perspectives on the axiological role of aesthetics in mathematics learning and relates them to pressing factors of concern in mathematics education, including student motivation, interest, creativity, and self-confidence. In a provocative article critical of the mathematics textbook industry, Anne Chandler and Miro review several sources of misconceptions that can be tracked to the sloppiness pervasive in some manuals. Among such sources, they identify, by considering just the notion of tangent, colloquial language, unwarranted generalizations, ignorance of the context, careless figures and diagrams, oversimplifications, and ill-defined concepts. From an excellent newly published yearbook of the National Council of Teachers of Mathematics, I selected for this volume the instructive contribution by Howard Iseri on using paper models to explore the curvature of various surfaces. Iseri skillfully places the problem in historical context and suggests student-friendly ways for teaching the notion of curvature in both Euclidean and non-Euclidean surfaces. Yuri Leron and Orit Hassan discern 4 different ways of distinguishing between intuitive and analytical thinking. They do it by placing mathematical thinking in a broader cognitive context that considers general theories of human learning. Judith Grabiner traces the unlikely circumstances of an eminent analyst, Joseph Louis Lagrange, venturing into the fundamentals of geometry with the illusion that he proved the parallel postulate. Grabiner shows that the incident and the paper that resulted from Lagrange's delusion, far from deserving laughs, allow reconstruction of the worldview held by the leading 18th century scientists, one fundamentally different from ours. Similarly, Harold Edwards recovers the algorithmic/constructivist meaning in Leopold Kronecker's mathematics, observing that not only for Kronecker but also for other distinguished past mathematicians, notably Évariste Galois and Niels Abel, mathematics meant something else than is generally implied today. Alluding to the late computational mathematics, Edwards asks whether a reconsideration of the definition of real numbers based on a logical foundation is in order. Carlo Cellucci discusses Giancarlo Rota's place in the philosophy of mathematics as reflected by Rota's references to the questions surrounding the existence of mathematical objects, mathematical definitions, and proof in mathematics, as well as the relation between mathematics and the philosophy of mathematics. Philip Bowers gives an engaging first-person account of the metamorphoses over the last 3 decades of problems related to circle coverings of a surface in various geometries and their interdependence on the changing role of topological considerations in geometry. Mark Collivan observes that inconsistent mathematical theories have worked for long periods of time and still do. He then examines in detail this apparent oddity, contributing to the ongoing debate concerning the conditions that lead to the failure of mathematical models in applications. Andrei Pelk analyzes the role of informal proofs, which he simply calls proofs, and formal proofs, or logical, and consolidating confidence in mathematical results as accepted by the mathematical community. Erich Klarreich reports on the Kerr-Ver conjecture, a result concerning the topological structure of manifolds in high dimensions. The conjecture states that a large class of shapes in dimensions higher than 126 are fundamentally related to spheres. Although a few particular cases remain unsolved, The proof is important for combining topology with differential topology and for settling the quandary in an unexpected way. In one of her periodical columns, Julie Rechmeyer traces the prehistory of the statistical student's t-test invented by William Gauzet to small sample problems that preoccupied, in fact, Darwin long before they preoccupied Gauzet. Stephen Strogart's plays with variations of Romeo and Juliet's love story to illustrate the explanatory power and the limitations of mathematics in selecting a spouse. He shows that sophisticated mathematical notions, such as differential equations, can be in fact employed to describe a large variety of real-life phenomena. Arbusman takes us to the movies to unscramble fine mathematical points in the twists of the plots. Game theory strategies, the mathematics of networks, and mathematical epidemiology all come to help. Is then watching movies enhanced by mathematical knowledge? With verve and conviction, Arbusman leaves no doubt about it. Following countless anterior writers on the number harmony embedded in human creativity, Vijay Iyer discovers the joy of tracing proportions of consecutive numbers of the Fibonacci sequence in architecture and in music. Finally, in his first volume in the series, Nick Baumgarten described a living project at the time, the idea of a mathematics museum in Manhattan, which, as many of us know, took shape shortly after. While taking the author on a midtown tour, the group of mathematicians who planned the museum offered a humorous account of the ubiquity of mathematics. Besides these contributions, in the introduction to the first volume, I also mentioned other interesting and worthy of attention writings on mathematics published roughly during the 2009 calendar year. Thank you for listening to this video on the best writing on mathematics. See you next time.